Number 33. We're looking for the definite integral, or in other words, the area underneath the curve of 1 over x minus 3 to the power 2/3 from 2 to 4. When we take a look at the picture of the graph, this is a graph of 1 over x minus 3 to the power 2/3, and we can see that the area that we're looking for, we're going to integrate across a vertical asymptote. So this is something that we have to be careful of, we can't do. Now, what we could do though is we can split it up into two separate integrals. One on the left side of the asymptote and one on the right side of the asymptote. So I've shown that here. That yellow area is going to be defined by that yellow integral, and the blue area is going to be defined by the green integral. So we have here since we're integrating to an asymptote, we need to use a limit. So we're just going to formally write this with the limit as a goes to 3 from the negative side. So what we're going to end up doing is integrating from 2 to 3. And then we're going to do the same thing, but we're going to lose a limit as a goes to 3 from the positive side. So that means that the green integral, we're going to integrate from 3 to 4. So I'll go ahead and integrate these. So we're going to end up with the limit as a approaches 3 from the negative side. The antiderivative of this is going to be x minus 3. Increase the power by 1, we get power positive 1/3. And then we need to divide by 1/3 to account for the exponent. So there's my integral, and I'm going to integrate that from 2 to a. And since I have a in there still, I need to write this as a limit. Plus, now this part is going to be exactly the same because it's exact same integral, except we just have different bounds. So I'm going to approach 3 from the positive side. This again is the same integral. It's going to be 3x minus 3 to the power positive 1/3. And I'm going to integrate from basically 3 to 4. Okay, so 2 to 3 is going to be one integral, 3 to 4 is going to be the other integral. So when I plug this in then, I'm going to end up with, when I plug in the a equals 3, I'm going to end up with 3 minus 3, which is 0. So I'm going to end up with 0 minus, I'm going to plug a into here. I'm going to plug 2 into the integral, so I end up with 3 times negative 1 to the power 1/3. So that works out to be negative 1, so I end up with positive 3. Plus, I'm going to do the green side here, so I'm going to plug in 4 into this, so I'm going to end up with 3 times 4 minus 3 to the power 1/3. That's going to be equal to 1 minus, when I plug 3 into there, I'm going to end up with 0. So there's my area from the green part. This is the area from the yellow part. And when I work this out, I get an area of 3. And this makes sense because this graph is symmetrical across that asymptote. So on one side it's going to be an area of 3, the other side is going to be an area of 3. So the net area, or the value of the definite integral, is going to be equal to 6. So then the answer is A.